My name is Annex. There's not so much to tell about me. I'm not formally, not professional security researcher or something. I'm just a dude. And I was kind of forced to do this talk by a good friend of mine who has been asking me for like a decade to visit one of the events he attends. He basically attends every event. I don't. So this talk is basically exclusively for him, but it's also for you as well. So have fun. Maybe it's a good idea to start off with a few questions, as so many do. It's a question that has been asked quite a lot in talks, I guess. So how many of you have a Wi-Fi router? That's some people. It's not as much as I expected. So how many of you have a smartphone? That's more. How many of you trust your Wi-Fi router? That's not many. How many of you trust your smartphone? All right. Actually, that's pretty encouraging, at least for me, because it shows you're actually skeptical of security issues, I guess, on those devices. I'm afraid many people are not, and that's why the first topic I'm going to talk about is Wi-Fi routers. I guess I'm gonna tell you. I'm not gonna tell you a whole new story here. So Wi-Fi routers can be safe, they can be fun, they can be great for surfing wirelessly, primarily. But they can also be a menace, especially if you have default passwords set up that are pretty much easy to guess or even plain readable. So there's been a lot of talk about this. There's like 5 to 7 common models here in Germany alone that you can basically have a script calculate the default password for and just have free Wi-Fi, right? And of course, it's not that simple. People may change their passwords. Some routers have default passwords that we just did not reverse engineer yet, I guess. Some seem to be safe over the course of time. But in general, you could say that there's a lot of models out there that have insecure default passwords and are still in use. So if you go along an alley here in Germany, you will find like 50 boxes and maybe 30 of them still have their default password. They still have the default password on the admin page as well. So you could actually change things. And for some people that may be cool. If you happen to, be out of bandwidth for your cell phone, there's free Wi-Fi, right? But it's also a problem if you have grandparents or maybe your parents even don't change that password. You're gonna be fucked basically by just entering their network, kind of drive by. So that's a problem. Totally forgot. Think about your parents. And even worse, that's not the end to the menace of Wi-Fi routers. Usually a Wi-Fi router is, if it's Linux-based, is a system of a chipset that is usually produced by huge companies, a company like Broadcom or something, and they give you a development kit with it. They have a nice demo board, and other companies come and get this development kit and kind of make their products and put them out there. The trouble is they don't make updates for those machines. So it's not only that you can access a wide range of networks, you could possibly do whatever you want with those networks, like have ports forwarded to you or lock the owner out or something. But they're actually running old software in many cases. And so, yeah, I'm just forgetting to skip through here. Please forgive me, because I didn't have time to prepare this so much. Oh no. So there's reasons for this. I basically mentioned one of them. You have those chip producers. They basically do the initial part of the software, give you a development kit, and the companies making the final product are basically rebranding them. They make their fixes, they make their changes, probably add a gizmo or two maybe, but they are not the masters of their code. They basically depend on the chip developer to give them updates. They could sometimes they do patches if you have a good vendor like I don't know. I wouldn't call D-Link good, but they make updates if something breaks. You can download an update from their page. And so even if there are updates, many people don't know that they are important. Many people don't know that they could be installed, and many people know they don't know that it's a problem at all. So there are some reasons out there. Many vendors claim that it's just too expensive to have regular updates, and they will only move it if it's really, 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 really dangerous. And an update is needed to prevent like total mayhem. But actually, they won't even do that. So their reasons, they're just not convincing. So those systems are Linux, right? So let's just fix all those systems. Well, first of all, Linux isn't Linux. It's a sad but hard truth that I had to learn. I did a lot of embedded development myself, trying to modify those systems, trying to get them to do my bidding. And what I learned is even if the source code, for example, for the kernel is available, you might be locked out of the bootloader, so you can just install a new kernel. It just ends there. And you have to resort to like accessing the hardware, disassembling the bootloader to find some way to work your way around the signature and to update the router in the end. I'm sorry, I'm getting a bit too technical. So coming with that, sorry. Yeah, Linux not being Linux is best imagined if you have like a desktop computer, and the full experience it should be like you can build a new kernel, you can make all devices run somehow by getting your device drivers right, compiling some kernel modules, sometimes even more exotic kernel modules that will sometimes even be proprietary. Sorry. Yeah. So after all, it's really messy. You don't really want to do that without proper support. You would like to have the dev kit, for example, from the chip vendor. That would totally help, but usually you don't get to that. There's a contract you have to sign. Usually you have to pay a lot of money to get access to those things. And if you're not in education or something, you can basically forget that. I'm independent. I don't have any university backing me, so I wouldn't get the nice stuff. So that annoys me. It's really messy. And nobody wants to do that. Actually, there's people who love reverse engineering stuff, people who love finding things out, but this is a multiplication problem. You don't have just one router out there. You have like hundreds of them, hundreds of models. And if you have fun disassembling like one bootloader, maybe the second won't be funny anymore. Maybe the third will be really annoying, and maybe the fourth you won't do at all. So after all, we need some way around that. It would be nice if we just got the complete sources for every distribution that's out there, not just the kernel sources, but also the sources to their web front ends they use, or the VPN solutions that are installed and stuff. And it would be nice, so I would say give us all your code, but I'm just saying that. No, nothing will happen. So, next up is smartphones. You can see I'm skipping over it because in the course of the development of this talk, something changed. My point was kind of made by somebody. So we're not going to talk about Apple's and Microsoft's today because that would be too easy, right? Just doesn't make sense to bash them. So Android is Linux too, right? But it has the same problem somehow. So in the Android world, you have chipset vendors, people like Broadcom again, or MediaTek. There's a lot more. And if you're not Samsung or like Google, you don't control the complete chain of creating this product. So you usually have a chipset vendor, and if you're a chipset vendor, you basically put together such a system where you have a system on a chip, you have some fancy gizmos attached to it, and you basically put it all together in a nice package and tell people this is the new generation of smartphone technology. Usually this ends up in a demo board with some vanilla Android attached to it. So now you have to find someone who wants to be Samsung. Of course, that's easy. There's literally hundreds of companies out there trying to do this. And those companies would be the product vendor. For example, I have a device from Vico. It's a French company doing the exact same thing. And they basically make a nice design, you know, with shiny 3D animations and gloss on it and stuff. And they figure out how to pack the PCB, the battery, and everything into that device. And they basically will prepare a campaign for that, launch the product, and then, of course, money. And that's how far they think. Usually, this goes on for like a year or something, and then something bad happens. For example, like an exploit could be a bug that just crashes the device and bricks it or something. But in our case, let's assume it's an exploit. So usually, Google would assess the exploit, would really deeply look into it, or Samsung. It's not just Google. A serious company would look into that exploit, devise a fix, fix the bug, make a nice package, and push it out to the users and bug them to basically install it because it's so important. It's an update. You have to do it. And then there's how many other vendors do it. So this is a huge problem. They don't do anything. They just sit it out and hope nothing will happen. They hope nothing will happen. So let me tell you the story of my weekend. On Wednesday, I believe it was Wednesday, good friend called me and he said, well, I'm going to Easterhegg, and you know, we have a problem. There's 2 workshops where the people couldn't come, and couldn't you come over and like do something? And I was like, oh, a workshop? No, I can't do a workshop. Maybe I can do a talk. What's the furthest away day I can do something? And he said, yeah, well, Monday. I had a little idea talking about the lack of software updates on Android and on Wi-Fi routers. And I was kind of joking with him, saying, yeah, well, the really good example to show how big a problem that is would be something like kernel level remote code execution. But when does that ever happen? Like when you can reach it? So I don't know, out of a guess or a hunch, I just Googled that phrase. And few days earlier, as it happens, there was an exploit was made public. So you can see it was actually found in 2016. That's the name and the researcher that found the exploit. And what it basically does is own your PC remotely with full powers. You're not root, you're beyond root. You define what root is, your kernel level. And it's actually pretty easy to write exploit for this because you can link against klibc directly, but it's out of scope. So, what about this bug? It's something you should be earnest about. That's why I had the wordplay with Ernest and Kernelst. It's Oscar Wilde novel. You don't have to get that, but it's serious, it's earnest, it's severe, it's pretty bad. It's really bad. So, but everything needs a context, and even this exploit is not almighty. Turns out it just refers to the receive message function. I don't know why it's wrote receive from. It's basically the same. It gets linked in glibc to the syscall receive message. Concerning UDP used with the message peak flag. That sounds very technical. Basically, what this does, and it's a totally legit use of code. I have to stress that, and I will stress that multiple times because names will show up, and you will hate those names. And no, it's all cool. You can do that, and the bug is on the kernel side. Every software I will tell you about from here on is perfectly innocent. The kernel was the problem actually. As you can see, the current kernel version is something around 4.10 or maybe 4.11 already. I don't know. This was 4.5. Still a pretty recent kernel. Many stable releases have not yet made it this far. So what you can definitely say is that no Android device has such a recent kernel. And what you can definitely say is that probably no Wi-Fi router out there has such a kernel. And so maybe to clarify the context, we have to clarify what UDP is. Maybe not everybody knows that. Let's rehash. It's TCP sister protocol. TCP is basically a stream-based protocol. You have a two-way connection, and you can write to the other side, you can read to the other side. The order will not be changed, and it will be guaranteed to be delivered if possible. UDP, on the other hand, is a packet-based protocol, so you have no guarantee over the order, you have no guarantee over the arrival of messages, you have no guarantee at all. You might get an error back, you might. So it's lighter than TCP, that's one of the main reasons we have it. It's very versatile, you can basically build TCP on top of it or some other protocol. and it's used in some pretty important parts of the internet, like DNS, that gives you google.com or any other domain you could possibly want. And it's also used in DHCP, which is the protocol giving you your IP address when you enter a Wi-Fi network or some other network that has automatic address distribution. So those are pretty core. Those happen to be everywhere, those two protocols. It is also used to penetrate network address translation, which is a measure or a technique your Wi-Fi router and other routers will use to make multiple users use one connection, basically. I will explain this in detail now. Well, not really, as it turns out. The reason we have IPv4 is that the reason we have NAT is that IPv4 is running out of addresses, and we have a replacement UDP. What the fuck am I? We have a replacement that's IPv6, and that one is not coming along very well. It's getting better. It's being implemented here and there, but not everyone has it, and many people still just get an IPv4 address to use the internet with, and that's why we have NAT. So basically, if you have a computer here and a computer there, the NAT will note and remember which computer wanted to talk with which site on the internet, and when the response comes, redirect it to the correct computer, to the computer that actually made the request. So that's NAT. The industry tends to tell us that NAT is a security technique. It is not, just like virtualization is not a security technique. You should really not trust any machine that runs one thing to be completely disconnected from the other thing. There's always ways around it, and CPUs have caches. So it's wrong that NAT is a security technology, but right now it may actually be the sad truth, at least till we know more. Why am I saying that? Because the situation with this exploit is pretty complex and pretty vast. It could be the end, but I'm pretty sure it won't be will not be the end. But it's probably gonna raise some eyebrows here and there and make people pretty nervous. Maybe even make someone release an update who hasn't released an update in 10 years. I don't know. So what we have to find out is which software is affected. And this is crazy, because usually you would do the reverse thing. You would see which software has a bug. But this time we have to look for software that doesn't have a bug. We have to look for software that uses totally legit code on a broken kernel and will therefore forsake your system and your whole security. And that was pretty adventurous, I can tell you, the past few days. I didn't have that much time to do it in detail, but I was so shocked that I kind of decided to make this the bigger part of the talk. I was actually just going to reference it as, here's one perfect example why you should update your operating systems, even on embedded devices, even on your Wi-Fi router. So IPv6 is affected as well. That is another way to get around your NAT. If you are so lucky to already have IPv6, many ISPs have not yet found out how to configure a firewall for IPv6. They just have IPv4 rules. It's pretty devastating. So this could be a problem as well, but I didn't look too deep into it. If it works, it works. If it doesn't, it won't. So if you're on this Wi-Fi right now, you won't have NAT anyways. If you're on like the local Wi-Fi with your cell phone, your firewall won't help you. There will be no NAT around you. If somebody could exploit that bug, and you would have some software running that is prone to this attack, bye-bye. So, are you really sure nobody in this room has Skynet already? I have Skynet. So, what software would really do that? Message peek is a flag that makes the kernel give you the next packet. In this case, could be the next few bytes on another protocol, but in this case, it will give you the next packet without deleting it. So you can just take a peek. Is there something interesting for me? And if there's nothing interesting, you can just go on with your life. If there's something interesting, you let the evil intruder become root and just be done with it. So keep in mind, using this combination is totally legit. It's just an interface the kernel offers, and the kernel broke. So even if you hear a few more popular names here, or if you don't curse the software I'm going to put up now. So what apps do actually use that call? I did a quick search, downloaded all the Debian and Arch sources, and grabbed through them. I have a fast internet connection at home. So, oh, that's actually too big. Just a sec. Won't work. Sorry. Hey. So now everything is going down. I don't know what happened. Okay, there's a lot of packets. I found like 800 packets when I started out just looking for message peek, so it's not that uncommon. Famous German security researcher said, well, that's not so uncommon. I can't cite any case. He was shown few cases in the ensuing hours. So there's loads of programs that possibly could expose this bug. The art is finding out which programs really have this bug. So the first thing that came into my mind when I read UDP was the DNS protocol, because it's the most core, most essential protocol of the internet. The internet wouldn't work the way we know it without it. In this case, you had to check like core libraries, the glibc library, for example, how they handle DNS requests, how they ask the server and wait for the answer, because that's the point where the exploit could actually be used. And turns out there's no danger here, no apparent danger here. let's say a bit distanced. Fefe checked glibc, diedlibc, and DJB. I checked Bionic to be safe. It's a derivative of other libs, so it was pretty improbable that they actually added something like that. But I wanted to be on the safe side, and it doesn't look like DNS would be affected anywhere. Because I'm a script kiddie and use Node.js, I also checked libuv. Because it's used almost everywhere for event management and a lot of stuff, but it looks safe to me. So that's the good news. In more good news, people speculated that systemd would be affected, which is a system. We have a good German word for it. It's called eierlegende Wollmilchsau. It's basically the application that brings up your system, checks the time. If you have a service here, it can totally receive a package, start the service, pass on the message, just like iNet was doing a few decades ago. No. It's very popular. Many distributions use it. Debian has it as default. If that would be exploitable, we all would be fucked. So there was one line over there. It said receive message peak. If the peak variable was set. Fortunately, I checked which file descriptor type it was calling, and it was a netlink socket. It's not UDP. The kernel should, if the kernel was not again in error, the kernel should totally call the right receive message or receive from function, not the UDP function. So, phew, that was close. So let's get over to the bad news. What's probably affected is anything local, of course. It's a remote exploit that goes to kernel level. You usually have software locally that would expose that exploit. I looked into a few things I could think of. Any netcat version has it. Netcat is a program to just pipe network streams here and there. It's like the Swiss Army knife of networking, and it's probably affected, just as Nmap, very important security researcher tool, etc. There's even OpenSSH is a netcat implementation. If you don't have a netcat, OpenSSH will give you this version. Even it seems to be affected. And keep in mind, it's not affected as in it does something wrong, it's affected as in the kernel will harm it if it does that call. So, BusyBox could be, there's one case where I'm pretty sure UDP sockets could end up being called with this message peak flag. There's also an iNetD implementation, but I think that's a control port. I didn't have time to check it in depth because it was really confusing in that file. BusyBox is, I don't know, it's pretty clean, but it can be disturbing sometimes. So, what's really a problem is DTLS. If you know TLS or heard of SSL, it's what usually makes your internet, your browser connection safe. DTLS is the version for datagram-based protocols, and it's basically used by banks to trade a lot. So it's kind of an important protocol, and not many people actually know it outside of the realms where it's used, but it exists, and it has been used for some jobs quite extensively. I really hope those people are aware of it, because I checked some implementations. This is just, don't be angry at OpenSSL again. It didn't do anything wrong this time. So DTLS seems to be affected, and that could be a really big problem. Although the markets didn't crash, as far as I know. I hope my talking about it will not change that. And yeah, so let's come to really bad part. Most of the Wi-Fi routers out there based on Linux will have some kind of embedded Linux low size system, basically being based on BusyBox or some lightweight tools that they can use to do stuff other systems do with hundreds of megabytes in, let's say, 4. So I looked into DNS mask, because it was speculated it would be vulnerable too. Turns out it is vulnerable. So as far as I checked, please don't take this as an absolute verdict, because as I said, I didn't get to check everything very deeply. I couldn't do like a live exploitation test on it because it just didn't work, and I had to abort the test in order to write the rest. So VPN software is also probably affected, but only if it uses, for example, the Ike program. I found some suspicious lines in there as well. But the really bad thing is DHCP, because it's going to be used. We can be sure it's going to be used. The rest is basically would be bonus. So your Wi-Fi router is probably affected. If your provider doesn't force upgrade it, or the vendor gives you an update, you're basically only protected by your NAT. So think about whom you let into your Wi-Fi. If it's actually the case, and that should be verified. I really don't want to have a final verdict on that yet, but it's UDP, it's used with that flag, and it seems pretty bad. So also virtually all cheap Android devices, and that's why I explained the whole food chain of Android earlier. Somewhere in this food chain, people will just try sitting it out, probably don't make an update, and that's why this vulnerability can even be, probably even be exploited in 10 years. If somebody happens to have like a cheap Chinese Android phone that is going to run in 10 years. So this also shows another problem we cannot control because it's not open source. There's a lot of voice over IP software out there and video software out there, like Facebook, Skype and stuff. We can't look into their source code. Of course, they have external audits, but in this case, we would actually have to see if they use the syscall on the binary. It's possible. I just didn't want to download Skype right now to check it, but this should be checked as well. And I obviously didn't do it, but the essential thing is voice over IP protocols use UDP to break through your firewall to enable direct communication between the video chat partners. So it's probably gonna happen, and they're probably affected without knowing it yet. The hotspot function on Android uses DNS mask as well, because it's a very nice program. I use it myself to just set something up quickly. I hate the config file and I hate the config syntax, but everything else it does quite good. And finally, this is basically the core problem of this. Somebody at some point in the future could like give you an app that is totally legit using this syscall. You just don't have a kernel that was patched against this bug, that was fixed. And he could just use this bug. And of course, it's Android. You have to press OK. I grant this app every network access it wants. But that's the kind of click almost everyone does. Even I do, because I'm paranoid, but that's a pretty standard request. You want to talk to the internet? Okay, do it. So Android does things to prepare stuff like that, to prevent stuff like that, but it could ultimately be exploited, and it could basically happen to me if I don't see it coming. If in 1 year I will have forgotten about this probably, and somebody will pass me an app, and yeah, fucked am I. So let's come to the really scary part. Your internet service provider usually has a box at the side of the street, cell phone tower, I don't know. Those are usually big Wi-Fi routers or big routers, usually running Linux, usually needing some kind of authentication. And because providers are the kind of people who want to pay nothing and take money for that, and basically complain how expensive nothing is. They use free radios. It's a radios implementation. Radios is a TCP or UDP-based protocol. UDP is pretty popular on radios. So I looked into this, and they are definitely using the right syscall, definitely using UDP sockets. If this setup would be running like this, they would, just as you are, would just be protected by their nuts and firewalls. If they had direct exposure to the network, they could be exploited, possibly, very possibly. If this whole thing works, it could be an Easter egg. Maybe this exploit doesn't even exist. I mean, it's like a wet dream, actually. So you really don't want to look into browsers. It's just scary. I did a grep, and I actually killed the grep because it was too scary. It's used in WebRTC. It's used in diverse other protocols. Someone should really have a deep look into that. So this is a rather broad scope. Every machine that cannot be patched, your PC, for example, will possibly not even have it anymore because you updated at some point and you got a newer kernel, and it's no problem anymore. Every server on the internet you can just update. That's no problem. So even if it's not OpenSSH remote code execution, it is still pretty bad. It affects services that run by default and that run in pretty prominent places and exposed places. So this is certainly a bad wolf scenario, just to get the Doctor Who reference here. And so you might be asking yourself, can't we just fix it? And the answer is, it's already fixed. It was not even deliberately fixed. Somebody discovered this bug retrospectively. This bug was fixed in 4.5, and he just discovered it last year, end of last year, when it was like 4.8 or 4.9, I don't know. So this bug is already fixed. That's not the problem. We can, if you can install a kernel, yeah, but not everyone can do that. And actually, at this point, I was going to show you how I would do it right now. With my cell phone, my famous Vico cell phone, because they actually published the kernel sources for my device, and I could just go into the kernel sources, apply a tiny patch that changes 3 lines, and I would be rid of the problem. The whole action, if it worked, would take maybe about 10 minutes, flashing, rebooting and stuff. And most of the time I would be angry about my cell phone because it was slowing down the process. But not everyone can do that as well. So we're in a bad situation right now. So this is the patch actually. Oh, it's 4 lines, but okay. Maybe you can see what happened here, but it's hard without the context. It's a very context-based bug. It's hard to spot. And so we can all speculate about the NSA putting it there, maybe even Skynet. I wouldn't go so far. I would say the NSA is just enough. So we should still check this out. As I said, I didn't do complete analysis of this thing. I just went through the whole code base and saw what could be affected, how far could the problem go. Something we call a threat assessment, but as it was not finished yet, is not finished yet, you can't even call it that. It's just a talk. It's just me talking, and please don't panic right now. Nevertheless, you should take this seriously, and if you can, we should fix what we can. Because as we know, in infection cases, it's always helpful to immunize as much people as possible, so they can actually have some. We can actually have something like herd immunity, and I think that is going to be a topic concerning this bug, and probably other bugs that will follow, because this was only a matter of time, and you rarely get such a beautiful one, and of course it wasn't the end of the world, because if that would happen on TCP, we would be standing here. Nobody of you would be here anymore. North Korea would have taken over, and that would be the end of the world. We were actually pretty lucky. It was just UDP. So we should make vendors release current kernel trees, at least. And that's the thing that has been done. You can put legal pressure on them. You could do public pressure on them. The thing that counts is that we get the sources, and the kernel tree, even if it's messy, would make me happy. But we actually need it's not there anymore. We actually need device drivers as well, because usually you may get a running kernel. You can even boot your device with a mainline kernel, like the top edge development kernel. But you won't get your baseband modem on the smartphone running, or you cannot use your graphics card because it uses a blob, a piece of software that you don't have the source code for, and you just have to talk to by a standard interface in order for it to talk to the graphics card for you. And this is a fairly popular problem, and so we want to drivers as well, and that's one thing you can we can fix it. Also, we have to think about the future. We should make more informed choices about the products we buy, and we should refuse having hardware pushed onto us, especially if it's not updated as well. So, conclusions. We need access to the kernel sources just to see what's going on. If they changed something, if they didn't patch something, we need to be able to see that, because it's pretty hard reversing that. And usually I'd say everything is possible. If it's just one incident, you can go miles to get an information. But if you have to do it in like 100 million cases for hundreds of models of smartphones and Wi-Fi routers, this is not going to be fun. That's something we can do distributed, but it's not fun for most of the people. So we need the drivers, we want them to, and we want the bootloaders to be unlocked in order to take full control. Of course, something needs to change with the general situation, as I described. You can't have this whole situation where the information is kept back by a chip vendor hiding behind the product vendor, hiding behind the sales clerk on your hiding behind the sales. What you know what I mean? It's been a long day. So if you don't do that, those markets may collapse, because consumers may lose trust. And this is just the first bug of this kind. I'm not even sure if it actually works, as I said. I just try to present a colorful assessment of the possible threat, if that all works out. So consumers might be pretty disappointed and turn towards Apple or Microsoft, and we can have that, right? So be aware, winter is here. So if you want, you can ask some questions. We have still a few minutes left, maybe 5 minutes of questions, if you have any. I'll sit.
Do you know if that is also usable as a local privilege escalation? So if
yes. And there's millions of ways to do it locally. You could write the code yourself, millions of ways.
You were talking a lot about the problem of devices, of embedded devices that don't get updates, with this bug in particular. But isn't this a problem for every bug with devices that aren't getting updated? And what makes this bug so special?
Well, I actually wanted to spread awareness about devices not being updated with this talk. I just came over this bug, and so the talk came more specific to this bug. I actually would have given you a broader scope with Internet of Things in it and many other things, but current events changed that.
So I have another question. What kind of network access is required to create such a UDP packet that triggers this bug? Is this an invalid UDP packet or invalid IP packet, or what needs to be done to exploit the bug?
So as I said, I never managed to reproduce the bug itself because of short time. As far as I understand it, you can send basically a pretty standard UDP packet. You just have to trigger the context in which the bug would be triggered, and for that I unfortunately was lacking the expertise and time. But the bug is real. It has a CVE number. It's rated 10 in every category. So I guess it is exploitable if it finds attack surface, and that's what I was assessing. I just didn't go into that. If I had more time, I would have done that. I actually was hoping to be able to demonstrate something quickly, but never works.
About your special device, there are still binary modules in the kernel.
Like on my cell phone.
Yeah.
Yes, I have blobs for the baseband modem, and I have blobs for the graphics card. And as I have seen it on all the embedded platforms I've worked on, be it Raspberry Pi, be it more router-specific chipsets with lower power, they all have kind of this problem. They will all require proprietary software at some point. Although the Raspberry Pi has been pretty unlocked very far. So the whole Raspberry Pi experience in my opinion, is about unlocking the NDA clauses on the hardware and getting the information to write open source drivers, and the Pi is the furthest one, I guess. You can always buy Google Nexus and stuff, something. You won't get a binary blob free hardware, but it will be better. You will have better support through the code base, and it will just work. But I guess that's not the phones most people can afford or want to have. So that's sad.
Maybe a bit more of a comment. Besides the smartphone market and tablet market, there are some silicon vendors which produce stocks for which we now have full mainline kernel support, graphics support, and video support. So on top of my mind, there's the Freescale IMX6, which has the AtomViv driver, which some colleagues of mine worked on and are maintaining. And
yes, but
there's also the Raspberry Pi, where there will be probably some good quality 3D acceleration in Mesa.
You're making a very good point there. Everyone get a Pyra. Everyone get a Pyra. That's one of the possibilities to get such a platform, and it will actually rock if it's ever done. And I'm pretty confident it will be done.
So it's not as fast as current smartphone chips in any way.
No, but actually don't require. Do we require like 8 cores with 2 gigahertz each? I think most of us don't.
Yeah. it's a trade-off. You have a fully open system, you have full control over the whole stack, and you can fix bugs. So that's worth a lot more than fast graphics.
You preach into the choir. Are you afraid? You shouldn't be.
Can you explain the bug if it's possible to understand easily?
Okay, yeah. Basically, the root of the bug was that the checksum, a checksum that was calculated in a second level pass of a logic. A checksum was wrong. The first time it does the right checksum, and the second time this check fails because something is gone already, or has been excluded by logic, and that's what's actually this small patch fixes, and it's hard to explain because I was actually sure what's happening and what was happening, and then it didn't work when I tried to exploit it. So I'm totally confused now. You should probably ask somebody else who's unbiased and didn't try for like half an hour to get it working, and was really disappointed because it didn't. So I think timing-wise, we're about through. We have like almost 2, and I think talk is afterwards. Okay. Thank you, and please, would you have a little applause for my friend Max here, who invited me, who made me come over here, who made me make up this talk while I was eating cake with my sisters on Sunday. He's the best, the very best. Thank you.